Hello,
Hello, sir. Good evening.
good evening. So let me start with second chapter, that is units and measurement. Okay,
Okay, sir.
units and measurement. In this chapter, we first discuss what do you mean by any physical quantity. Let's say if you have to measure mass of a particular object, so it would be some 5 numerical value related to the measurement of that given quantity and some SI unit in which that given quantity is being measured. Similarly, if you have to calculate time for an event, let's say it would be 2 hours. So 2 is any numerical value and R is any unit for this particular time. So we define music, any physical quantity if it is expressed in terms of some numerical value and is there any specified unit is defined for that particular measurement, that given quantity is called physical quantity. But some of the other terms like feeling, emotions, hunger, if I tell you, can you define any numerical value or specified unit for the measurement of these things?
No, sir.
So we can say these are not the physical quantity. So from this, we can conclude physical quantities are those quantities which can be measured in terms of some numerical value, and there must be some SI unit specified for that particular given measurement. Okay,
Okay, sir.
so physical quantity is nothing but the quantity which can be measured directly or indirectly in a unit, and in terms of which laws of physics can be defined. So now in this particular statement, I have defined you just two different words. First is directly measurable and second one is indirectly measurable. So we mainly divide this particular physical quantity into two parts. First is directly measurable quantity and the second one is indirectly measurable quantity. I'm giving you one example how to define this. Suppose if you have to calculate speed, do you know how to calculate speed, the formula of this?
Distance by time.
Good. So speed is nothing but distance divided by time taken. So if I tell you to calculate distance, you just need any meter scale and we start counting from the beginning of the journey till the end. So we can say for the measurement of distance, we don't need any other quantity for its measurement. Similarly, if you want to calculate time, you just need any watch or stopwatch. We don't need any other physical quantity for its measurement. So these quantities like distance, time, mass, for which we don't need any other quantities for its measurement are called as directly measurable quantity. Or we can say these quantities can be independent of other quantities for its measurement. But if you have to calculate speed, you must need distance as well as time. Otherwise, you can't find this particular speed with just one of any of the two values. Okay.
Okay, sir.
So the directly measurable quantities are those quantities which are independent of other quantities, and indirectly measurable are those which are dependent on other quantities. So in physics, we call this particular directly measurable quantity as fundamental quantity, and this indirectly measurable quantity as derived quantity. Is it clear?
Yes, sir.
Okay, just write it down, or you may take a screenshot. In which chapter you are in school?
We are currently in the 4th chapter.
Vector, motion plane.
The four.
Okay,
Sir, I have written.
good. The next thing is, what do you mean by fundamental quantity? And derived quantities. To define this fundamental and derived, I'm giving you one example. Suppose when you have started learning in your childhood, suppose for English language, what was the first step with which you have started learning this English?
Alphabets.
Good. It was the alphabet A, B, C, and so on to Z. On knowing these alphabet, we start rearranging them to form word like apple, ball, and so on. After knowing these words, we start rearranging them to form sentences and so on. So from this, we can conclude alphabet is the most fundamental for knowing this particular English language. So it will be just fundamental part. And rest of the all term, which is dependent on that fundamental, are called as derived part. Similarly, in physics, there are some quantity which are independent of rest of the whole term and on which all other quantities would be dependent. So those quantities are called fundamental quantity, and rest of the all quantity which are dependent on them are called as derived quantity. So from this, we can conclude the physical quantity which are independent of other quantity are called fundamental, and the quantities which are dependent on other quantity for its measurement are called derived quantity. Is it clear?
Yes, sir.
Okay. Next, we divide this particular fundamental quantity into two parts. First is base quantity, and there are some quantity whose property is different from this particular base quantity. We call them as supplementary. In base quantity, suppose you may have heard about the earliest branch of physics, which is called mechanics. And your whole 11th course deals with just mechanics. In mechanics, we deal with three different quantities. First is mass, next is length, and next is time. On knowing these three different physical quantities, we will be able to calculate velocity, speed, acceleration, force, linear momentum, work, and so on. So all of the quantity which deals in
Sir,
this particular, yes,
sir, can you explain that supplementary thing?
I will explain later. First of all, for this particular base quantity I'm defining you. Okay.
Okay, sir.
So in mechanics, we deal with just three terms: mass, length, and time. So in earlier days, base quantity would be mass, length, and time. But later on, due to advancement of physics, some more quantities were enrolled in this particular category, Suppose temperature, electric current, amount of substance, and last, which is intensity of light, or you may say luminous intensity. So in total, we have 7 different fundamental base quantity. There are 2 supplementary parts. First one is plane angle, or the angle which is formed on 2-dimensional surface. And the second one is called solid angle, which is formed on 3-dimensional axis or 3-dimensional region. It is called as solid angle. So we have mainly these 7 base quantity and 2 supplementary quantity. Is it clear?
Yes, sir.
Now we define this particular base quantity and we measure them in some specified SI unit. Suppose for the measurement of mass, it would be kilogram, length in terms of meter, time in terms of second. Tell me how to calculate or what would be the SI unit for temperature?
Kelvin.
Good. So it would be Kelvin. Electric current would be measured in?
Ampere.
Good. Amount of substance?
Mole.
And intensity of light?
Candela.
Good. Now for these base quantity, we define another term that is called dimension. I'll explain later what do you mean by dimension. But in terms of dimension, mass is represented as capital M, length is represented as capital L, time capital T, temperature capital K, electric current capital A, amount of substance mole, and intensity of light as its SI unit is candela, so it would be C. Is it clear?
Sir.
Okay, just write it down.
Sir, is it okay if I take screenshot and then write it afterwards?
Yeah, you may. Done?
1 minute, sir.
Okay.
Yes, sir, you can continue.
Okay. So the next thing is in this particular chapter is to define dimensional analysis. Dimensional analysis. So the first thing is, what do you mean by dimension? Or we may write it as dimensional formula, dimensional equation. So you must have learned in class 10th or in class 10th in mathematics, geometry. For any of the geometrical figure, we define some term, suppose length, breadth, height, depth, width, radius, diameter, and so on. On the basis of these terms, we would define the surface area, lateral surface area, outer perimeter, circumference, volume, and so on. So for that particular geometrical figure, these length, breadth, height, depth are called as dimension. But in terms of physics, dimension has certain different meaning. Suppose if you want to calculate speed, so it would be nothing but distance divided by time taken. Distance is nothing but measurement of length, so we can write in terms of capital L. Similarly, time, it is represented by capital T. So if we bring this particular term to the numerator, since it has +1 in the exponential, so on bringing it to the numerator, its exponential would become -1. Is it clear?
No, sir. Can you repeat again?
We have certain law of exponential. I'm defining you. Suppose if you have x to the power m multiplied by x to the power n, it would be x to the power m plus n. If base of two quantities are same and they would be related by multiplication, so the exponential gets added. Similarly, x raised to the power n divided by x raised to the power n, so it will be x raised to the power m minus n. Similarly, x multiplied by y and whole raised to the power n, it will become x raised to the power n multiplied by y raised to the power n. Is it clear?
Yes, sir.
There are certain more relation. Suppose if x raised to the power plus n or minus n, let's say 1 over x to the power plus n. So if you bring this particular term to the numerator, its exponential will becomes minus n. Okay.
Yes, sir.
Now, if you have x raised to the power n and whole to the power further n, power raised to the power, so it will get multiplied. Okay.
Okay, sir.
So these are certain exponential laws which we will use in this whole dimension.
Now, how did the t get -1 value?
Since the exponential of t in this particular part is just 1, okay? So if we bring this particular part to the numerator, using this particular law, its exponential would becomes -1, okay?
Okay, sir.
That's why I have written this.
Okay.
Now, just see, L is nothing but in terms of meter, it can be measured. Similarly, for the measurement of time, it would be nothing but per second. Now just see, we have this whole part is nothing but meter per second.
Yeah.
Okay. So it will define you nothing but the SI unit for the measurement of this speed. Okay.
Yes.
So we can write this is nothing but the SI unit of that given speed. So from this we can say speed is suppose any quantity if it is expressed in terms of the raised power of fundamental quantity, then this expression would define you nothing but the SI unit of that given quantity. So this expression is called dimension of that given quantity. Is it clear?
Yes, sir.
Okay. So from this we can conclude dimension is nothing but the representation of any quantity to the raised power of fundamental which defines their SI unit. So this is the meaning of dimension. Is it clear?
Yes, sir.
Now I'm defining you some basic dimension which you have to learn some basic dimensions or dimension formula. Let's say first length, breadth, depth, width, radius, diameter, distance, displacement, wavelength. This whole term would define you nothing but measurement of length. So we can express this whole term as capital L. Okay. Okay, Abdurrahman.
Yes, sir.
Okay, just take a screenshot. Alan, we are just continuing some minute.
Yes, sir.
Okay, sir, you can continue.
Okay. On the basis of which we define area. Area is nothing but product of any two different lengths. So it will be L square. Similarly, volume would be nothing but product of three different lengths. So it would be L cube. Now suppose if you have to calculate density, which would be nothing but mass divided by volume. Mass is any fundamental quantity, so it will be expressed as capital M, and volume is nothing but L cube, so it will be L to the power 3. So now if you bring this particular term to the numerator, its exponential would become
ml minus 3.
good. Similarly, speed, velocity, and speed of light. This whole term would define you nothing but LT minus 1. Next is acceleration, gravity, gravitational field. These all three would define you nothing but acceleration, and acceleration is nothing but velocity divided by time taken. So for velocity, we have LT minus 1. If we divide it by time, so it will become LT minus 2. Next, force, thrust, weight, torque, heat. No, just 1 minute. Tension and normal reaction. These all would represent same as force. Do you know the formula to calculate force?
Mass into acceleration.
Good. So we have m for mass, and for acceleration, it would be LT minus 2. So in total, it will become MLT to the power minus 2. Similarly,
The basic ones we have to by heart it, like the speed, velocity, speed of light.
yeah, I'm just defining some basic dimension for which you just remember this whole term so that you can define the rest of the other part. Okay.
Okay, sir.
The next one is work, heat, torque, energy of any kind. This all term would be same, which is nothing but force times displacement. So it will be ml squared t raised to the power minus 2. Okay,
Okay, sir.
just write it down or take screenshot. Just 1 minute, Ifra.
Okay, sir.
Yes, sir.
Done? Okay.
Yes.
Okay, we are just continuing the next part with some more students. Just 1 minute. Yes, Ifra, just read your question.
Okay, sir. So in the formula, x is equals to 3yz square. X and z have the dimensions of capacitance and magnetic induction respectively. what are the dimensions of Y in MKSQ system?
Okay. We will read this particular term in today's topic. Okay. I will
Okay,
define
sir.
these type of question today. Next one.
So next one is LCNR
Okay. We will continue that
represents
particular part
the
in the today's
physical
class.
quantities, inductance, capacitance, and resistance, respectively, the combination which have dimensions of frequency are
Ifra, we will continue that section as well in today's class. Okay. Now, on the base of dimension from last class, let me define quantity on the base of dimension into two categories. First one is dimensional, and the next one is dimensionless. Dimensional quantity means the quantity which having unit and on the basis of which we can express them in terms of raised power of fundamental quantity. So we can say dimensional term would be nothing but the quantity which having some unit. Now, if a quantity would have some unit, so it will be of constant value, or we can say it would have fixed value in the whole universe, in which the first term would be universal gravitational constant. It is represented by capital G, and it is equals to 6.67 into 10 to the power minus of 11 Newton meter square per kilogram square. So just see this particular whole value is nothing but a constant value, and it will have some specified unit for which we can define their dimension. So we can call universal gravitational constant as dimensionally constant value. Is it clear?
Yes, sir.
Similarly, if you have to define Planck's constant, it is represented by H, and it is equals to 6.626 into 10 to the power minus of 34 Joule second. So it again have a constant value and having a fixed unit. So on the basis of which we can define dimension, and its value would be remain same for the entire universe. So we can call it as dimensional constant term. Is it clear, Alan?
Yes, sir.
Ifra, any doubt?
No, sir.
Okay. Now there would be some quantity which numerical value may vary from question to question, but their unit would remain the same. So that particular quantity would be called as variable, or we can say it would have some changeable value like force. Force is nothing but mass times acceleration. So you would have different mass and different acceleration according to different questions. So on getting product of them, you would get different numerical value, but the unit for the calculation of force in all of the problem would remain the same. That would be Newton. So we can call this particular quantity as dimensional variable part. Similarly, pressure, volume, work, and so on. So these all quantity would be have or would have some changeable value, depending upon question, but their unit would remain the same in any of the given quantity. In the next part, suppose for dimensionless. The first term is the quantity which having constant value or fixed value, and there is no unit assigned with that particular term. So we can call it as having no unit. The first term would be real number. You must have learned from beginning of your class till 10th number from minus infinity to so on -1, 0, +1, and so on to plus infinity. This whole term would behave as a fixed constant number. Suppose 1, its value would remain same for the entire universe, and there is no any unit assigned for this particular numerical value. So we can say it is dimensionless. Is it clear?
Yes, sir.
Similarly, there would be pi, which is equals to 3.14. There is no any unit assigned with this particular number, and its value would remain the same for the entire universe. So we can say this is called dimensionless constant term. Similarly, there is another term that is called exponential function, which is equals to 2.72. Again, it is a constant term and there is no unit assigned for its particular measurement. So we can call it as dimensionless constant term. There are some quantity whose value would change. So we can call them as variable or changeable value. In this part, the first thing is angle. Angle is the only quantity in whole physics which having unit as radian. But if you calculate dimension of this particular angle, it will give you nothing but dimensionless. Suppose angle is expressed as length of r by radius. So L is nothing but measurement of length. So we can write it as capital L. R is nothing but radius. So its dimension would be again L. L and L would cancel out. So we're left with thus nothing but L raised to the power 0. So we can call this particular term to be dimensionless. That's why we express supplementary quantity in which we define angle or solid angle in separate category that is called supplementary quantity. Okay. So just see here, angle is dimensionless term and its value would change from problem to problem depending upon length of r and radius related to that particular circular or r problem. So we can define angle is the only quantity having unit as radian, but still it is dimensionless. Next thing is refractive index. You must have learned this particular topic in your class 10. There was a chapter called light and there was a topic refraction. Alan, can you define what do you mean by refractive index?
Bending of light, degree of bending of light.
Good. So it should be measured in terms of, or there was some formula to calculate refractive index?
Sin A by sin R.
Good. So it would be sin I by sin R, or would be speed of light in air or vacuum to the speed of light in that given medium. So it is nothing but ratio of same quantity in two different medium. And the unit for the measurement of that given quantity in two different medium would be remain same. So on taking the ratio, these two terms would get cancelled out. So we're left with just a constant value or we can say it is dimensionless term. And depending upon pair of medium to pair of medium, suppose for air and water, it was about 4/3. For air and glass, it was 3/2. Similarly, for air and diamond, it was 2.42 and so on. So its value, depending upon pair of medium to pair of medium, would vary, but its unit is dimensionless or have dimensionless term. Similarly, there was another term that is called relative density, or you can call it as specific gravity. Relative density is nothing but ratio of density of any substance and density of water. Okay, so in numerator we have density of a medium, and in denominator we have density of water. These two density would define you same unit, and if you take a ratio of them, then it would get cancelled out. So we're left with just nothing but dimensionless. Is it clear, Abdul Rahman?
Yes, sir.
Okay. Similarly, there is one more term that is called coefficient of friction. It would depend upon roughness of the surface which is in contact. Suppose some surfaces would be more rough, some surface would be smooth, and so on. So depending upon their roughness, its value would change from surface to surface, and it is nothing but a ratio of two different forces. So they would cancel out and gives you nothing but dimensionless term. So again, we can call this particular term as dimensionless variable term. So just remember this whole thing in your exam. They would ask you to define example related to these four different topics. Ifra, is it clear?
Yes. Yes,
Okay.
sir.
Just write it down or take screenshot.
Done, sir.
Good.
Done, sir.
Done, sir.
Okay. Now we have just defined quantity on the basis of dimension. Now there would be some formula, or there would be some quantity for which we have to calculate dimensions. So find dimensions of first universal gravitational constant. So for any of the quantity, the first thing would be to define the formula related to that particular given quantity. So for this universal gravitational constant, let force between any 2 point masses is equals to G product of masses divided by square of separation between them. So from this, try to simplify for this particular capital G, or bring this particular capital G to one side and rest of the other term to the other side. Like, since here r square is in denominator, so on bringing to the other side, it will move to the numerator. Similarly, m1 and m2 is in numerator, so on going to the other side, it will move to denominator. So it will become G is equals to F times R square divided by M1 into M2. Is it clear?
Yes, sir.
Now we have dimension formula for force, dimension formula for radius, and mass as well. Put them all and try to simplify to get dimension formula of capital T. Try to solve, everyone, and give your answer in chat box like this: M1 L2 P minus 1 like this way. Okay. Is it clear, Abdurrahman?
Yes, sir.
Okay. Try to solve. Good, Isra. Abdurrahman, you have to send your answer in chat box to MZ. Okay. Good. Alan, have you solved?
No, sir. I'm solving.
Okay. This particular term is called eta, a Greek alphabet, eta, and it is expressed for coefficient of viscosity. Viscosity is same as friction for two different rough surface. Viscosity is defined for any liquid. Just simplify it and try to obtain dimension for formula for this eta. Try to solve Ifra, Abdul Rahman.
Yes.
Ellen, should I help you?
Yes, sir.
First of all, just write dimension formula for force. It was mLt raised to the power minus 2. Okay. Next is r, which is nothing but radius, so it will become r squared, or we can write it as L squared. Divide by m, which is mass, and m, which is again mass, so it will be m squared. Is it clear?
Yes, sir.
Just see, in numerator, we have m raised to the power plus 1, and in denominator, m raised to the power plus 2. So we have two same quantity having same base, but different exponential, and they are related in division. So according to the law of exponential, their power would be get subtracted. So it will become 1 minus 2. Okay. Similarly, we have L raised to the power 1 here and L raised to the power 2 here, and they are related in multiplication. So their power would get added. And next, e raised to the power nothing but minus 2. So on simplifying, 1 minus 2 would be minus 1. L to the power 1 plus 2 would be 3. and t raised to the power nothing but -2. Is it clear, Ellen?
Yes, sir.
Just write it down. Done, Ellen?
Yes, sir.
You may recall this particular whole term, which was nothing but law of exponential. Okay,
Okay, sir.
you may take a screenshot of this whole part. Done.
Done, sir.
Now try to sum arrange this whole part, simplify this whole part, and obtain this particular eta to one side. And using dimension of rest of the whole term, try to get dimension for this particular eta. Try to solve. Just see, 6 is any number. Pi is also a constant. And we have already defined you for any of the constant number, it is nothing but any unitless quantity. So we can neglect them on the basis of dimension. Okay, Afra?
Okay.
F is force, R is radius, and V is velocity. Just see how to simplify it. Keep this particular eta to this side and bring rest of the term to the other side. Since all of these term is in numerator, so on going to the other side, it will move to the denominator. So we can write eta is equals to F divided by 6 pi R V. 6 pi is nothing but any number, so we can neglect them. So we're left with just F divided by R V. Now put all the dimension of this whole part and try to simplify. F is same as force, which I have written here, this part. R is nothing but length and V is nothing but LT minus 1. Put all the dimension and try to simplify. Ifra, check your calculation. Abdurrahman,
Yes, sir.
have you solved
I'm
or
doing,
should I
sir.
have?
I didn't get it.
Okay, just 1 minute. Just we have force, so it will be mLT to the power -2. Divide by r is nothing but radius. Alan, what
Yes,
would be
sir.
the dimension for this particular radius?
And
Good. And for velocity, it would be LT -1. Now, this L and this L would cancel out. So we're left with M. We have one L in denominator, and this term would cancel out. So on bringing it to the numerator, its exponential would become -1. Is it clear?
Yes.
Now, for this particular time, we have -2 exponential in numerator and -1 in denominator. So if you bring this particular term to the numerator, its exponential would become +1. So -2 plus 1 would become just -1. Is it clear?
Yes,
yes,
sir.
Okay, just write it down.
Sir, I have one doubt. How did 6 pi go?
6 is nothing but any real number, okay? And pi is also a dimensionless constant part, as we discussed in this section.
Yes,
So
sir.
if any of the quantity which is dimensionless, so we can neglect them, okay?
Okay, sir.
Done,
yes, sir.
Abdurrahman?
Sir.
Okay, there is one more term in terms of heat. Suppose if you have to calculate a specific heat constant, Q is equals to ms delta T. This S part is nothing but specific constant. Q is heat and delta T is nothing but temperature. So rearrange them to find this particular S. Here we have Q, which is nothing but heat. And I have just explained you in this part, work done, heat, energy, torque, this all would define you same dimension, that is ml square T minus 2. Okay, so just use in the place of heat this dimension and try to simplify it. Good, Ifra. On rearranging, you will get S is equals to Q divided by M times delta T. Q is nothing but heat, which having dimension ml squared T to the power minus 2. Here M, which is nothing but mass, and delta is nothing but temperature. And we know the SI unit of temperature is Kelvin, or we can write the dimension of this particular
Kelvin.
temperature as capital K. Good, Abdurrahman. Alan, too fast. Alan, have you solved?
Not yet.
Just see, Q is nothing but heat, which having dimension as ml squared T minus 2. Is it clear?
Yes, sir.
In denominator, we have mass, so we can write dimension as capital M,
Yes.
and delta T, which is nothing but temperature, so we can write it as capital T. Is it clear?
Okay.
Now this M and this M would cancel out.
Yes.
So just cancel out this. So what we're left with? L to the power 2, T raised to the power minus 2, and we have K in denominator. So on bringing it to the numerator, its exponential would become
Here is
minus 1. Good. So this would be your dimension for this particular specific heat. Done?
Yes, sir.
Okay. The next term would be in terms of electrical term. For any of the electrical term, the first we define as charge. You must have learned in your class 10th, there was a topic that is called electric current. Current is nothing but rate of flow of charge through any conductor. So it would be equals to charge flowing per unit time. So from this, you can rearrange it to get Q is equals to I into T. I is electric current having dimension capital A, and T is time having dimension capital T. So the dimension of charge would be A into T. The next term is to define voltage, EMF, and potential difference. These all would define you same term. It is equals to nothing but work done per unit charge. We have dimension formula for work done and we have dimension formula for charge. Just put them and try to simplify it. Try to solve, everyone. Good, Ifra. Abdurrahman, check the exponential for t. Alan, have you solved?
I'm doing.
Just say we have work done. Work done is nothing but ml square. There is some error, Alan. Just say work done is ml square t minus 2. Divide by charge. Charge is nothing but a into t. So just write it. Now, there is no m other than this, so we can write it as m. Similarly, it would be L square. We have t raised to the power plus 1 in denominator. So on bringing it to the numerator, its power will become minus 1. And we have already minus 2 in numerator. So in total, it will become minus 3. Is it clear?
We can't divide t by t.
If you want to divide these two terms, so it's having exponential minus 2 and it having exponential minus 1. So according to the law of exponential, on division, the exponent gets subtracted. So it will become minus 2 minus 1. So it will become minus 3. Is it clear?
On dividing, we'll get minus 2 and the down one is plus 1, right? So minus
Yeah.
2 by 1 it will be, right?
No. The rule of exponential says whenever two quantities in or in division form, so just subtract the exponential of them. Like I define you just second law. If x raised to the power m divide by x raised to the power n, so the exponential gets subtracted. Okay.
Okay, sir.
So we have t raised to the power minus 2 and t raised to the power plus 1. So if I subtract minus 2 minus 1, it will become minus 3. Okay. Now we have a having exponential 1 in denominator. So on bringing to the numerator, it will become a raised to the power minus 1. Is it clear, Alan?
Yes.
Okay, just 1 minute. Ifra, here A is nothing but dimension of electric current. It is not same as area. Okay. Okay, now we have three different terms. First one is resistance, second one is capacitance, and third one is inductance. These are just property of a particular substance. Suppose for resistance, you must have learned in your class 10 in chapter electricity. Resistance is nothing but opposition property to the flow of charge through any substance. So for this, we define voltage is equals to current into resistance. We have dimensional formula for voltage. We have dimensional formula for electric current. Try to get dimensional formula for resistance. Similarly, capacitance is nothing but the charge storing capacity of a particular device, like battery, which stores electrical energy in the form of chemical. There are some devices which stores electrical energy in the form of charge, just as condenser, which is used in fans. So for this, Q is equals to C times voltage. Q is charge, which having dimension as AT. V is voltage, which having dimension this. Try to simplify to get C. Similarly, inductance is nothing but the opposition caused to the flow of variable current by any coil is called inductance, or you can call it as self-inductance. For this, energy is equals to half L I square. We have dimensional formula for energy, dimensional formula for electric current, just rearrange them to find L. Is it clear to everyone?
So what is inductance?
Inductance is nothing but property of coil to oppose variable current through it. You will learn these whole three terms in your 12th class in more detail. Okay.
Okay, sir.
Try to solve the dimension of each part. Efra,
Yes, sir.
your question was to convert this particular A in terms of L square,
Yes, sir.
but A is nothing here. It is just for electric current. It is dimension of electric current, not the area. Okay.
Okay, sir.
So how do you find V? Like what's the formula
V
for
is
V?
nothing but voltage, which we have calculated this whole part. I've written here voltage, or we can write it as V.
Okay, sir.
Ifra, in place of I, just write A. Your answer is correct. Good, Abdurrahman. I'll just check the exponential for T. Otherwise, the rest of the term is correct. In the formula for voltage, here we have just T raised to the power -3. And the question here we have just I. I is nothing but electric current having dimension capital A. Good, Ifra. Let's just see. R is equals to nothing but voltage divided by current. For voltage, dimension formula is ml square t raised to the power minus 3 a raised to the power minus 1 divided by I, which is nothing but current, so dimension would be A. Bring this particular term in numerator, its exponential would become minus 1. So in total, it would become mlt to the power minus 3, a to the power minus 2. Okay? Good, Ellen. Good, Abdurrahman. Here E is energy. Good, Ifra.
So we should leave that 1 by 2, right?
1 by 2 is nothing but any real number, which
We
would
should
be
not like
dimensionless.
count it, right?
Yeah, just neglect it. Good, Abdurrahman. Good, Ellen. So we have just defined these three terms, R, L, and C. So on the basis of this, there would be some arrangement. So they will ask you like L by R times C, 1 by root under L times C, and 1 by R under root L by C. These would be four different combination regarding this LCR. Just remember, or you may find this whole relation, or you may find dimension of this whole part. This term, this term, this term would define you same quantity. The dimension of these three parts would be nothing but just T. Okay, and the last part would be dimensionless. You can definitely find this particular result since you have L from this part, you have R from this part. Just put them and simplify it. You will get T for the dimension of this part. Similarly for this and similarly for this. So there was a question in assignment. There were four different options and try to obtain which other combination would define you the dimension of frequency. Frequency is nothing but inverse of time period. So it means the dimension of frequency would be T to the power -1. Okay. So there the relation would be R over L, or it would be 1 over RC, or it would be under root of LC, and so on. Is it clear?
Yes.
Just write it down. Done?
So,
Okay. I'm defining one more term. Suppose there is a quantity which is called permittivity. And there is one more term which is called as permeability. Permittivity is nothing but permit or allowing tendency of getting electrical interaction by any medium. So permittivity is defined as the tendency of medium which enables the interaction of charge or which enables electrical interaction in that medium. That tendency of medium is defined by permittivity. You will learn this particular topic in more detail in your class 12. We have to define the dimension of this particular part. So it is represented by a Greek alphabet epsilon naught. So we can call it as permittivity of vacuum or absolute permittivity. So how to define the dimension of this part? For this, force is equals to 1 by 4 pi epsilon naught charge square divided by r square. We have dimension formula for force, dimension formula for charge, and radius as well. Simplify it to get the dimension of epsilon. Now, on solving for epsilon naught, permeability is nothing but the tendency of medium which allow magnetic interaction in that medium is called permeability. It is represented by mu naught. So we can call it as absolute permeability, or you can call it as permeability of vacuum. So there is a relation in these two terms by C is equals to 1 by root under mu naught epsilon naught. C is nothing but speed of light. So just find dimension from this part, put it here and try to obtain for mu naught. Is it clear?
Yes, sir.
Okay, first of all, try to find epsilon naught. Just simplify it as epsilon naught is equals to q square divided by f times r square. Dimension of each part and try to simplify it.
How did you arrange it?
Since epsilon naught is in denominator, so on bringing it to the other side, it will move to the numerator. And f is in numerator, so on going to the other side, it will move to the denominator. And 4 pi is nothing but any constant number, so we can neglect it. Done? Is it clear?
Yes, sir.
Andarima? Okay.
Yes, sir.
Now we have dimension formula for charge, force, and radius. Just put them and simplify it. Good, Ifra. Do this particular problem in your homework. This part. Alan, have we done?
I'm doing it.
Okay. Durrahman, are you solving? Just see. There is some error. Q is nothing but charge having dimension A into T square divided by F, which is force, mL T raised to the power minus 2. R is nothing but distance or length, so it would be L squared. So on bringing m to the numerator, it will become m to the power minus 1. We have L to the power plus 1 here and L to the power 2 here. So on combining, it will become L cube. And on bringing to the numerator, it will become L to the power minus 3. In next part, we have t raised to the power minus 2 in denominator. On bringing it to the numerator, it will become plus 2. And we have already t to the power 2 in numerator. So in total, it will become t to the power 4. Now we have a raised to the power 2. So it will be a squared. Is it clear? Or you can simply expand this relation as a square e square and bring all of the part to the numerator, or you may write it as m l to the power 3 t to the power minus 3. Now move all these terms to the numerator, it will come out to be this part. Is it clear, Abdurrahman?
Yes, sir.
Alan, any doubt? Just write it down.
No, sir, no.
How to simplify this particular part? First of all, take square both sides or squaring both sides so that this particular root would cancel out. Now rearrange them to find mu naught. With diaphragm.
So how do you remove that square?
Just squaring both sides, so it will be c square divided by mu naught epsilon naught. Okay, so bring this mu naught to the other side, so it will be mu naught is equals to 1 by c square times epsilon naught. Is it clear?
Yes, sir.
C is nothing but speed of light having dimension Lt to the power minus 1. Put this in this part. We have already dimension of epsilon naught as this part and try to simplify it. Done. just put C is nothing but LT to the power -1 and squared it. Epsilon naught is nothing but m to the power -1, L to the power -3, T to the power +4, and A to the power 2. So on squaring, it will become 1 divided by L squared there is some mistake, Alan. Just see T to the power -2, L to the power -1, L to the power -3, T to the power +4, A to the power 2. We have only one m, so bring it to the numerator, so it will become m to the power +1. We have L to the power -3 here, and we have L to the power +2 here. Since we have C squared, so just square this particular whole part. So it will be L to the power 2 and T raised to the power 2. Is it clear, Alan? You have
Yes,
done
sir.
mistake here. Okay. Now we have L to the power -1 in the denominator. On bringing it to the numerator, it will become +1. Similarly, we have T to the power -2 here and T to the power +4 here. So we're left with T to the power 2. On bringing it to the numerator, it will become -2 and A raised to the power -2. Abdurrahman, is it clear?
Yes, sir.
Okay, just write it down. Abdurrahman, done?
Yes, sir.
Okay. So we have just finished all of these dimensions. Now, in next class, we'll proceed principle of homogeneity and how to define or what would be the application of dimension analysis. So we have mainly 3 different applications of dimension analysis. Okay. So first of all, just revise this whole part and try to memorize that particular first part means dimension of some basic quantity. Okay.
Okay, sir.
Okay, then we'll meet in next class.
Thank you.
Thank you.
Thank you.